This is the Building Automation Monthly Podcast with Phil Zito, episode 106. Hey folks, Phil Zito here, and welcome to episode 106 of the Building Automation Monthly Podcast. And in this episode, we are going to be discussing integration, specifically systems integration. This is going to be part of a three-part episode, so this will be episode number 1. And what I want to point out real quickly is, if you're in sales or you're in engineering and you're not a tech, you're still going to want to listen to this episode because this episode is going to have a lot of nuggets in it for you that are going to help you kind of better understand how to take your designs to the next level, how to take your scopes to the next level. It's going to have a lot of gotchas when you look at scopes and you're sitting there thinking, oh man, I've got to add all this cost to a job. I'm going to point out kind of where you do, where you don't. And so there's going to be a lot of nuggets in here for you. So I really encourage you to look past the fact that it's systems integration and that's quote unquote a technical topic. It's got this perceived difficulty to it. I believe after we go through this episode, you're going to see it's really not that difficult. And for those of you who are more on the technical side, I think you're going to find this really cool because we're going to do a lot of case studies. We're going to look at a lot of examples as we move through this kind of three-part series. So without further ado, let's dive in. So in this first episode of this series, we're going to unpack kind of what integration is and the three types of integration. This is going to be really important for us to ground ourselves in, because if we don't, I could say integration to you, and that could mean anything from you simply wiring a dry contact from a fire alarm into your BAS, all the way to you writing some custom code that is taking a RESTful API from some other system and pulling it into another system. That could be your interpretation of integration. So it's really important that we ground ourselves on what integration is first. This really became apparent to me when I was reading a post in a Facebook group, and the guy was asking me basically, hey, I've got this one system and I want to integrate it to another system. Do I need to rip all these parts out? And I was kind of just asking around different aspects of integration, and it became apparent to me that there's really no one out here teaching integration. There's no one out here. I mean, everyone talks about integration from a sales perspective. They're like, oh, systems integration, smart buildings, greater outcomes, business objectives, informing the customer, making them in control of their environment, all these kind of marketing buzz bingo words. But yet, when you actually say, okay, how, folks are like, well, pay us, $50,000 and we'll tell you how. And it's like, that's all well and good. And I do think folks should definitely get paid for their expertise. After all, I run a business where people buy online training from me about building automation systems. So this isn't UNICEF here. We're not giving everything away for free. People should be paid for their talents. But at the same time, I mean, as an industry, we really need to ground ourselves on what system integration is. So a little background about me. Prior to starting my business, I had a role at Johnson Controls where I was responsible for a lot of technical integration. And in that role, I got to see a lot of different things. So what I'm going to talk to you about here are kind of not specific things from what I encountered in that role, but rather just generic things that are going on in the industry that folks really need to be aware of. But realize that the thing is this is going to become something that not even a big company like that is having to face, but this is something that even, simple property managers are going to have to face when they have customers or tenants coming to them for their, really small office space that maybe no real large building automation manufacturer is going to touch because there's just not enough profit in the job for them. But yet these tenants are coming and they're saying, hey, I've got a smart home. I could turn on my thermostat from my phone, Why do I have this thing that it sounds like the building's going to explode whenever I go and I adjust the thermostat on the wall? Why do I even have to adjust the thermostat on the wall? So you're going to find more and more operators and just smaller organizations are having to embrace these kind of concepts. And I think a rising tide floats all, or what is that? A rising tide raises all ships. I don't know the saying. I heard it in, where did I hear that saying? I was watching Daredevil, I think, on Netflix, and one of the bad guys said that saying to justify his criminal enterprise. But that's neither here nor there. All right, back on topic. So what's going on here is we have to establish a common framework, a common set of understanding for systems integration. And we do that by looking at the three different types of systems integration. And as I see it, based on my experience, it's physical integration, protocol integration, and programmatic integration. So we're going to dive into each one of these. We're going to give 3 examples of each one, and then that's pretty much going to take us through this episode. So this is going to be really valuable for you to focus in on, because a lot of you are going to be budgeting or approaching an integration like it's maybe a protocol or a programmatic integration when it could simply be done with a physical, or vice versa. So we really need to go and ground ourselves on that right now. Okay, so this first integration, the physical integration. This is something that pretty much, if you've been in the industry for more than about 2 years, you've encountered this in some way, shape, or form. And this is quite simply the simplest integration to do. And it's something that I think, quite honestly, folks should be taking a lot more advantage of. So the first example of a physical integration would be a fire alarm integration. This would be where you have a general alarm, or maybe you have a more specific alarm on the fire panel, and then you are simply running some wires from your controller, from an input in your controller to that fire panel, and then that fire panel has a relay it closes, and once your wires are connected to that set of contacts, they're connected to the fire panel, and that relay closes, it creates a connection, which then says, hey, we've got a fire alarm. So that's a really simple way to go and detect if you've got fire alarm. But let's look at a more advanced example. What about lighting? So oftentimes we hear lighting integration is complicated. Can't quite figure it out. And it is complicated. I agree. I mean, you've got concepts of multi-zones versus spaces. You've got protocols, who's in lead of the command, all this sorts of craziness going on. But let's think about it for a second. Lighting. What's something everyone could really do that would be really simple? Well, what if we just, let's say you don't even have a lighting system. Let's say all you have are light switches. It's not terribly hard to go to a light switch, put a IDEC relay and interrupt that light switch with the BAS. And now you have lighting control. That's another example of a physical integration that the average person can do. And when I say do, let me be clear, because I don't want anyone like shocking themselves and killing themselves. You can do, meaning you can say, hey, I want to go and actually pull in lighting control of this space, but you should have an electrician do it. You should have someone who actually knows what they're doing with electricity to do it. But you yourself, as a building operator or as a facility manager, could go and hire an electrician, or if you have an electrician on staff, you could have them do that. It's relatively easy, relatively inexpensive. And then all you have to do is simply go and do that. And actually, a lot of occupancy sensors that are basically doing the same thing, where they're interrupting the light command based on occupancy, they have auxiliary outputs. And some of them even have command inputs. So you could actually go and enable lights via that way as well. So you're already starting to see just 2 examples. Another example is going and having access control, where you simply have auxiliary outputs off of your access control. Now, granted, a lot of access control is going power over Ethernet IP right now, but there still are some access controls that have auxiliary outputs, auxiliary contacts that you can connect to. So you're starting to see one of the first things I would always talk to folks about when folks are like, hey, I want to integrate, and I got to do these APIs, and I got to do BACnet and LAN and Modbus, and it's all protocol, and it's so confusing. And I'm like, well, what if you just physically wire up to them? I mean, I think we get so caught up in this whole open API and open protocol and everything's smart and digital this and digital that that we forget, it's not bad sometimes to just wire up to stuff. That's okay. It's perfectly fine. And quite honestly, if you don't have technical acumen, let's say you, meaning you, the installer, you, the designer, you, the programmer, you, the scope writer, salesperson, whatever, I would much prefer you do physical wiring than try to figure out protocols and integrations. Because in my experience, when we get to those quote unquote higher level forms of system integration, that's where things tend to fall apart. Because folks go and they try to integrate, but they don't exactly know how to maintain the integration after it's been done. And that's where things just get all kinds of ugly. So like I said, physical integrations, they are just a physical connection between two systems. And some examples, as I mentioned, are fire alarm integrations, lighting integrations, and access control integrations. Now we come up to my personal favorite integration. It's one that I think a lot of folks misunderstand. And because they misunderstand it, it either gets done wrong, or it doesn't get done at all, or folks are just fearful of it, and they don't need to be. And that is protocol integration. And when I say protocol integration, for those of you who are listening who come from an IT background, you're probably immediately going to like, oh, so he's talking about IP, or he's talking about CoAP, or he's talking about HTTP, or he's talking... No. That's all programmatic stuff. That's stuff where you have to use data adapter patterns and all sorts of jazz. Now, I realize for some of you who are not technical, you're hearing all this and you're like, oh my gosh, data adapter patterns. What does any of this mean? Don't worry. Quite honestly, you really don't need to know it. I mean, you really don't. I would rather have you focus on outcomes and focus on what kind of systems are needed to achieve those outcomes. Heck, if you figure that out, you'll be ahead of the curve. But when I'm talking about protocols, what I'm actually talking about here is BACnet, LAN, and Modbus. The big three, right? Those are the big three protocols, at least for the building automation industry. And when I say building automation, I specific to HVAC. Because, oh my gosh, I told myself I'm not going to go on little rabbit trails in this episode, because I've been doing that a lot lately. But I have to. It's right there. I've got to go down it. It's I can't help myself. So building automation, right? You would think that building automation systems would mean HVAC, would mean lighting, would mean access control. That was something that was very interesting for me when I went over to Europe recently, is that they look at building automation and they look at it as truly building automation. You tell them building automation system and they think HVAC, lighting, access control, AV, all these systems. I'm not saying that they haven't figured out how to tie them all together, but that's what they think of a BAS. Then we look at BAS here in the United States, at least where I am, and a lot of folks, naturally, you say BAS and they say, oh, the thing that controls the HVAC. That's the association. So when I say BAS protocols, I'm looking at it truly from a United States perspective of these are the things that tie into HVAC. I know all fully well that access control, AV, lighting, there's a slew of other protocols that apply to that. But specific to what we're focusing in on, we're focusing in on BACnet, LAN, and Modbus. Now the thing is, if you understand the concepts I'm about to go through, it's not going to matter if it's Dolly, it's not going to matter if it's MQTT, it's not going to matter if it's CoAP, it's not going to matter if it's RESTful HTTP. None of that is going to matter. What is going to matter is the concept. So there's really three big concepts. And if you're driving, just remember to come back to this because this is something you're really going to want to write down. But there's really three big concepts, and then we'll go into the three examples. I'm going to spend a lot of time on protocols, so that seems to be where a lot of folks struggle. The first concept is understanding the protocol. If you look at BACnet, if you look at LAN, and you look at Modbus, they're three completely different protocols. I mean, that's obvious from the name, but I think for some folks, it's not obvious. So BACnet is a discovery protocol, and it's very much oriented around that you have a device, a BACnet device, and this device has different properties inside of it, and it has different objects. So it goes device, objects, properties, right? That's how a BACnet thing works. So if you think about it, right, a car has a bunch of doors, and the property may be number of doors. So the device may be car, the object may be door, it may be tires, it may be engine, and then the properties are the details of those objects. So in the case of a BAS device, you may have a advanced application controller that has an object called analog input, and that analog input has a property of present value, of name, default description, priority array, all sorts of stuff. And so what I tend to find, so that's number one, right? So I'm not even going to go down what I tend to find. I'm just going to do these real quick, these three things. So you got to understand the nuances of the protocol. The second thing is that you have to understand where you are with the protocol. So I often will find folks that are using field level protocols, meaning stuff at the field bus, field controllers, serial protocols, those kind of things. So think, stuff downstream from the supervisory device. And then they're trying to integrate those to network layer protocols. So they're like, I got BACnet MSTP and I'm going to tie it into BACnet IP. And then they expect the rules to be the same, but they're not the same. So you really got to understand that. And then the third and final thing is that you've got to understand who takes the lead. And this is true of almost all protocols. So here's the deal, right? Let's say that you have an elevator system or a lighting system. And let's say with the elevator system, you're pulling it via Modbus, and you've only got read-only points. Well, in that case, you're pretty safe, right? I mean, you really can't do much damage. I mean, you can't go and override the elevator because that's a life safety thing. But then let's say you've got lighting. And lighting, let's say you're pulling via BACnet IP. Well, who's in control? Because you may pull in the light command. You may pull in the light level. So then you run into these situations. Is it the local light switch? Is it the actual lighting system? Is it the BAS? Who has control? These three concepts, right, of understanding the protocols, of understanding the layer you're at with the protocol, and then understanding who's in charge. These are the three biggest things that tend to cause issues with protocols. And this is where I find a lot of folks really struggle. So for example, example one, you go to a building, and this building has an existing Allerton system. Let's just say Allerton Backtalk. System I grew up on. And it's not even called Backtalk anymore. I think it's called like Ascent or Summit or something like that. But you've got a system, and it's a BACnet system. And then you've got let's just say a ALC system, and it's BACnet. And then your customer says to you, I want a single front end. I want to have a single front end. I'm sick of going and having two front ends. I've got to log in. I want a single front end. And you're saying to yourself, okay. Now the question becomes, what do you do? How do you approach this scenario? Well, there's multiple approaches you could take, and I think this is what throws folks for a loop. And so you really got to understand the customer's intent. Does the customer prefer one of the systems over the other? Do they prefer the user interface over one of the others? Because that then looks completely different than if they hate both user interfaces and they want a standalone user interface. Do you see the difference there? Do you see how that could be completely different? So let's talk through both of those scenarios, right? So one is customer loves, let's say they love the ALC front end. And I don't have any preference for anything out there, folks. If you listen to any of my podcasts, I think I've recommended one software in all 106 podcasts, and that was the Visual BACnet by Optigo Networks, just because that software is pretty freaking awesome. But that's the only thing I've ever recommended out of everything. So I don't have a dog in this fight. But here's the deal. Let's say that in this hypothetical situation, they love ALC's graphics. Well, in that case, what you're going to have to do is you're going to have to do two things, right? First, you're going to have to figure out, where's my disconnect? Well, going back to our third kind of gotcha with protocols, we need to know who's in charge. You're going to have to make a decision. Do I get rid of the Allerton UI and pull that in to the ALC system? Or do I keep the Allerton UI and do I then pull that system into ALC, but then ALC has priority over that Allerton system? Can you kind of see the variables? And this is where you've got to actually go and map this out graphically, because you've got a lot of scenarios going on. For one, what if you've got data sitting in the server? What if you've got averaging logic? What if you've got global logic that then if you go and get rid of that server, it disappears? That's quite possible. And you've got to figure these things out, and then you figure out what level you're going to pull stuff out. Now, one of the worst things you can do with a integration like this would be to say, I'm going to get rid of all the Allerton supervisory devices, and I'm going to pull all the Allerton field controllers over onto the ALC system. I see folks do this. They're like, all right, I know what I'm going to do. I'm going to get a Jace, and I'm going to get rid of those BCMs. I'm going to get rid of them. I'm going to pull all my VLCs and VLXs. Those are Allerton field controllers. And BCMs are their supervisory devices. At least back when I worked with that stuff. It's changed since then. But they're going to pull all that stuff off, and they're just going to put it on a Jace. And it's like, and Jaces are Tritium Supervisors, by the way. Sorry if I'm saying stuff that's obvious, but I don't know what level you're at. And I just want to make sure it's clear. But, I'm going to pull this stuff off and I'm going to get rid of it. Okay, I've done that? That's really freaking stupid. I'm sorry to say that if that's your strategy. But, I was at a... Now, granted, it could have been stupid because of my own stupidity. But I was at a hospital 3 hours north of Seattle. I ripped out the Jaces and I went to put in my own supervisory devices, ignoring the fact that there was global logic in those Jaces, and it was just all kinds of bad juju. And the problem is that with some systems, you can't see what's in the supervisory devices unless you have access to their software. So my recommendation personally is to always leave the supervisory devices alone. Leave that system as intact as possible, and then all you're simply doing is shadowing objects that are in that system. Now, there's so much more to this, and I could literally spend probably the next 20 episodes going through this, but suffice to say, you just need to understand what layer you're connecting at, and you need to understand what you're doing. Okay, so pulling us back. So I mentioned the first was pulling it into the ALC, so that was example one. But what if the customer doesn't like either UIs? Actually, they hate both UIs. They're like, man, this ALC stuff, this Allerton stuff, I hate both of it. I really like those new, HTML5 graphics from so-and-so company. And so they decide to go and get a server from so-and-so company, and they want to pull both of those systems in. Now you've got kind of a triplet scenario, right? In that who's controlling across those three systems, who's in lead. But then also you've got to go and say to yourself, how am I going to pull this stuff in? And this is where, once again, you got to know what you're doing. You got to know the 4-tier architecture of a building automation system: servers, supervisory devices, field trunks of field controllers, and I/O. And then you're going to be going and putting a break in between that supervisory server layer. But you also have to realize that if you break that, there might be a break in the logic in the server. And so this is where you kind of got to understand the systems, but you also have to understand the protocols. Now, a third example, because I realize we're running a little long. Can you tell I'm really passionate about this topic? I mean, it's already 25 minutes into the podcast, and I'm like, I'm only on example 3 of number 2. But the third is actually going and putting in field level device. So one of the things you'll often hear about LAN, about BACnet, about Modbus is that since they're open protocols, you technically can add devices to existing trunks and everything will be good. Now, there are nuances around device speed, around addresses, all sorts of stuff. But the point is that if you're using the protocol correctly, you can go and let's say you have an existing building and it's all Siemens field controllers, their BACnet line, their PX line. And you're going and you want to go and add BACnet devices that are also on this trunk. And actually the PX is a bad example because that's IP based in most scenarios. Okay, let's say you got Johnson Controls FECs. Okay, not their new FECs that are IP based or FACs, but they're older ones that are MSTP based. So you've got these, and let's say that, for whatever reason, new facility director comes and he's like, I don't like those. I want to use so-and-so's VAV boxes. Let's just say that they want to go and use, we used automated logic already, so they want to use Delta VAV controllers, the older Delta version, not the IP-based. And so they decide, hey, we're going to go and take MSTP, and we're going to go and hook those up as well. Now you've got a couple different variables here. You want to know the bus speed that's being used. You want to know addressing conflicts. You want to know network ID, all this information. But in theory, you can go and just slap these controllers on that trunk as long as the wiring's the same, as long as the speed's the same. So what I've found, really, folks, in this kind of much deeper dive into protocols than I'd intended when I came up with my show notes here, but is that you've really got to understand the protocol. You've really got to understand where you're working in the protocol. And you've really got to understand who's in charge. So those 3 things are going to make a huge difference as you're working through protocol integrations. And specific to protocols, I'm actually looking at doing a mini course in the very near future. I'm not sure if it's going to come before my programming fundamentals course or after my programming fundamentals course, but I'm looking at doing like a 2-hour course on protocols, kind of what is BACnet, what is LAN, what is Modbus, how do they work, what are the different layers, what are the different setups, kind of nuances, all that stuff. Because I've been getting so many questions about protocols lately that I think that's the best way to handle it. Alrighty, so moving along onto programmatic. Now, what does programmatic mean? Well, so up to this point, as far as like really having to write some code and do some fancy stuff, you really haven't had to do much, right? I mean, with physical integrations, you do wiring. With protocol integrations, most of that stuff's auto-discovery. You might have to do a little bit of typing with Modbus if you have to build a register table. But with programmatic, now what you're doing is you're going and actually having to write programs. Now, the most common thing you're going to do is called a data adapter pattern. And a data adapter pattern, what that is let's say that you have a weather station API. And that weather station API, which an API is an application programming interface, is going to be sharing outdoor air temp. Let's say it's going to be sharing outdoor air temp. And you want to take outdoor air temp and you want to share it to all of your field controllers. So basically what you want to do is you want to take outdoor air temp, you want to pull it into your BAS, and you want to take it from maybe a weather station. And that weather station has an API. But what you need to do is you need to essentially take that data coming out of that weather station's application programming interface, which allows you to interface to the application, which in this case is the weather station application. You want to take that, you want to basically look at the format that that information is coming to you in, and you want to adapt it or tailor it to be a format that your BAS can accept. So this is the most common form of integration, and that actually, or of programmatic integration rather. Protocol integration is the most common form of integration. But when you're doing this, that's a very common example. We'll go and we'll discover a weather station, and we'll go to the API. We will then go and grab the data and pull it in to the BAS. Now, in this case, you've got to have someone who could write code, and then here's the deal. Whereas with protocol and physical integrations, you're pretty much like the easy bake oven. You set it and forget it. With programmatic integrations, you then have to maintain that integration. And this is kind of when I hear folks talk about smart buildings, and you read all the marketing out there about smart buildings and, you know, how they can walk on water, and they can fly through the air, and, you know, they're going to miraculously remove climate change and bring world peace about, and whatever else, you know, is in those glossy marketing sheets out there. The reality is that you have these smart buildings, and man, there's a lot of really good system integrators out there who can get those buildings doing some really cool stuff. Problem is and you know what? If anyone tells you this is not the case, then they're lying to you. And I know that's a really strong statement for me to make, but I've just seen it time and time again. You get the smart building going, and 9 times out of 10, the two biggest issues are getting all the different business leaders on board with what the outcomes are going to be for that building and getting it done early enough. And the second is actually maintaining those integrations after the building's built. No one says, well, I don't want to say no one, very few people. There's a couple companies out there that communicate this, but very few companies are out there saying, oh, hey, by the way, your smart building, yeah, you need to have a strategy after that smart building goes together, because if you don't, then that thing's going to be in hand in just, you know, a couple months. Hand meaning the mechanic or the operator is going to go and manually override the commands of those integrations. So, for example, you may do a lighting integration, or you may do a weather or a schedule integration via an API, via some programming, and then all of a sudden the API changes. So now the data link is broken and stuff's put in hand because there was no governance put in place. There was no oversight put in place to watch these APIs. And I know some of you are thinking, well, it's a smart building. Why should I have to do this? Why should I have to go and watch these APIs? Isn't that the whole point of the smart building? Well, yeah, but I mean, you change the oil on your car. You go and you change the filters in your air conditioning at your house. I mean, I'm sorry, but it's not completely maintenanceless. Is that lacking maintenance? I don't know. I don't know what the proper English is for that. But regardless, you get the point. You're going to have to do some maintenance on these systems. And part of that maintenance is you got to accept, if I'm going to do a software upgrade or if something's broke, I need to have a process to say, is the API still working? Is the network still up? Did someone change an IP address? Someone close a port down? That's why it's really important that you understand IT if you're going to be in the smart building space. And by the way, I have the best darn IT program out there, bar none. It is amazing. It will take you from zero to IT knowledge warrior in just about 20 hours. And it's completely online, so you don't even have to hop in an airplane. I really encourage you to check that out. It'll be in the show notes for this episode. But with that being said, it's really important for you to have a plan when you're doing integration. That's the biggest thing, is after you've gone and done programmatic integration, you've got to have a plan. So what are the three examples? Well, three most common examples, I've already gone through one of them, which is weather stations. Pulling in weather stations, making sure, because here's the cool thing about pulling in weather stations is that you can go and do some really cool stuff. You can go and get humidity, you can go and get dew point, you can go and get wind speed, you can go and get sun position, cloud percentage, and you can do some really cool stuff with all that information. You can command your lights, you can command your shades, you can command your outdoor air, you can change your start and stop times on your equipment and your schedule based on forecasts. You could do some really cool programming if you pull from a weather station versus, a 10K Type 2 outdoor air sensor that's just sitting there and you're just hoping it's getting the right reading and hoping it was installed in the right spot. Another example of programmatic integration is scheduling. A lot of folks, they especially in school districts and in universities, you'll see that folks are leaning towards integrating their BASs with their scheduling systems. So in this case, this is largely a programmatic interface as well, where you're going and consuming the API, the application programming interface, from the scheduling software, and you're pulling that into your BAS as a point, and then using that point to be acting as the schedule for a specific room or piece of equipment. So that's another example. And the third and final one is going and working with electrical information. So you may be able to get an electrical feed from your local utility. And what I would often like to do is pull that electrical feed in, as well as the electrical runtime equipment data, and basically create a BTU chart, really realize how many BTUs I'm using, as well as get a full snapshot of the entire utility consumption and demand of the building. That way, if you want to do, demand reduction, if you want to do some form of load reduction, you're able to do all that. Once again, though, those three examples are dependent on programming. You need to maintain the APIs for all of those, because what if the scheduling software changes? What if the utility decides to update its API or change its API? You're starting to see how kind of all these things come together. All right, so let's recap real quick. I mean, this has been, and if you're listening to this the day it went live, it's right after daylight savings time, so some of you are already hurting, and here I am dropping all these concepts on you. But this has been a pretty deep episode. I normally don't go this deep, but figured you all would like it. So we talked about the three forms of integration: physical, protocol, and programmatic. Talked through three examples of each, and we talked through the gotchas of each kind of protocol. So if you didn't catch that, or not protocol, of each kind of integration, if you didn't catch that, I really recommend you go back to it. Now, the show notes and any links that I referenced in this episode are going to be available at buildingautomationmonthly.com/106. Once again, that is buildingautomationmonthly.com/106. In next week's episode, we're going to be talking through why are we doing integration, what outcomes are we looking at, user preferences, who's going to support it, what systems that are actually in there. We're just going to be taking a deeper look at some of the kind of thought process that goes behind this and just unpacking that. So it'll be very useful for you if you're just thinking about integrating some different systems like a lighting and a BAS, or an AV and a BAS together, and you're just kind of thinking through, how am I going to approach this? That'll be a really good episode for us to go through. So that being said, once again, thank you so much for being here. I encourage you to go to buildingautomationmonthly.com/106. There you will find that I have links to several different things, as well as the timestamps for this episode, so you'll know where all the different cool tidbits are. I also encourage you to go check out my online training programs. I'm just at about a little bit under 2,000 students at the time of recording this, so I'm just so thankful to every one of you out there who's a student of mine. Thank you so much. All the success stories of how this has impacted your sales. It's gotten you a job. It's let you get a promotion. You're writing it into your development goals. Those of you who have invested in your entire team going through these programs together, I'm so thankful for you. And I encourage you to check out buildingautomationmonthly.com/store. Check out the best online building automation training, bar none, in the world. It is the best. And you can really have some large impact on your career, as well as your team's proficiency, effectiveness, and profitability through these programs. So thanks a ton once again. I will talk to you all next week, where we discuss the second part of the system integration. And then I believe we're going to interrupt this series, as I'm going to be doing an interview with Iodium, which is going to be awesome. We're going to talk about remote access and security related to having multiple buildings tied together, a topic that I'm super excited about. It's something that's very important, and they have a unique approach to doing it. As you all know, whenever I bring folks on, it's not a marketing fest. They're not just pitching their product the whole episode. We're actually diving deep and unpacking the topic, so it'll be a ton of fun. All right, folks, that's it for right now. Thank you so much. Keep pushing, keep growing. There's so many of you out there I know who are working so hard day and night to get better at this. And I'm telling you, with the talent gap that's in the industry right now, you invest in yourself, and your future opportunities, I'm like getting goosebumps as I say this, your future opportunities are limitless. So thanks a ton for being here. Take care, and I'll talk to you all again next week.